used is, oh, it is platform independent. That's as soon as someone talks of Java, the first thing someone will say, oh, it's a platform independent language, right? Okay. So let's discuss about what exactly is the meaning of platform independence in case of Java. Okay, that's one thing. Okay. Another important thing is we'll discuss is related to what exactly made Java popular. What made Java popular? It alone was not. There's some component which is available in Java, which actually brought Java into limelight. It triggered the popularity for Java. No, there's something called its use on the web applets. And so that's the next thing we'll be discussing. Okay, just a look at what exactly how it was different from what was happening then, right? And third, we'll discuss is object-oriented programming. Fine, so that's what we are going to mainly discuss about. Okay. Okay, so let's see this. Right? So let's begin with the first point, which is about what does one understand by platform independence. When people say, oh, it's platform independent, what exactly is meant by platform independence? Okay, to understand this, let's look at other language like C and make a comparison between how do we write a code and then how do we compile and finally execute the code. Fine. In case of C language, what is done, and in case of Java language, how it is done. It's just a comparison, small comparison. So if we have a code in C language, how do you finally get it executed? The steps would be, oh, you got your code in C language, and that's your code. Okay, what would you do? Compile this. Okay, when we compile the code, the output of compilation would be some executable. Okay, this is because of you compile the code and you get an executable. Okay, and then next step. Oh, this execute. What is an executable? What is it made up of? Binary code. But what does it contain? Instructions. Instructions in a machine language. Fine. Instructions which are according to a platform. Right? See, for example, if I take a C code, compile it on the Windows platform, the output of compilation is an executable which has instructions to work on the Windows platform. When the instructions come from an instruction set, that instruction set is nothing but the instruction set which is for the specific platform where you are compiling. Okay, so the output of compilation, this executable would work on a specific platform. Okay, fine, this is how it is. Fine, that's the normal thing, right, for C language. Okay, let's compare this with what happens in case of Java. In case of Java, what exactly happens is, yes, you got your Java code, source code for Java. When we compile this, the output of compilation, yes, what is it? The output of compilation, we call it as, it's known as the Java bytecode. Okay, the output of compilation here is Java bytecode. And what is this Java bytecode? Yeah. What is the Java bytecode? Like executable? It's like executable. It's also binary code. Fine. Which is nothing but instructions. Instructions for a platform. Which platform? The Java platform. Fine. See the difference. You can see the difference. When you compile, where you compile, accordingly the executable is created. Here you compile, wherever you compile, independent of where you compile, the output of compiler is the same. Given a particular Java code, the output of compiler is always the same. Because the target is not the native platform. The target, fine, the target of compiler is, it is targeting the Java platform. It's creating code to run on a Java platform. Okay, fine. So Java bytecode is nothing but instructions for the Java platform.
In JRuby and Jet and all that languages, whenever you will compile,
Yeah,
it will be again a Java bytecode.
Java
That's why
bytecode. They all compile to Java bytecode. Yeah.
that is how
So any language which gives compilation to Java bytecode, yes, that's the one which is working on the Java platform.
how this executable file and how this
Yeah,
Java
yeah.
bytecodes
Now,
are
what is needed for the Java bytecode to run? So at runtime, what is needed is we need a JVM, fine, or we'll say JVM interpreter, which interprets and executes on a native platform. So running is done by the JVM interpreter. For execution part,
this
fine,
executable file and this Java bytecode. Both are again a binary code. Then how it is different?
this one,
Yes.
okay, I have compiled my code, then I don't need to give the source code. That's one thing. Fine.
Once I have compiled, I don't need
Okay. Now this compiled code will work where?
in any JVM machine.
Any machine which has a JVM. That's it. What about this?
Here it will be source code.
It will work. The executable will work only on the machine where you compiled it, not on a different platform. Fine.
It's
You
a
have one
machine
layer, right?
independent. It's a
Yes.
machine
This is
independent.
giving us the independence. What we have here is for every native platform, find different types of native platform, we got a JVM interpreter. Okay, fine. That's how the independence comes because of this layer. Okay, it's interpreted at runtime. Fine, we say it is interpreted at runtime. Fine, because it is interpreted, fine, it is supposed to be slow, right? Fine, but it's not that slow because of lots of efforts which have gone through, which it has gone through. Fine, this JVM interpreter has been, fine, the work here has been tremendous. What they have done is they've put in lot of efforts and there are lot of techniques used. Okay, one such thing is they use something called JIT compiler, just in time compiler. Fine, see, in case of interpretation, right, if you got a loop, how will the interpreter work?
For the loops.
Fine, it interprets each time the loop. Here it realizes it's a loop. Let me compile this into native. It has to anyway compile into native each statement.
Yes.
But then when it finds it's a loop, okay, let me do it in one chunk. Right, something like that. Fine, we call it as a just-in-time compiler. Fine. for execution purpose, and that's how they have made it much faster. It's much faster and not slower. It used to be initial days, yes, it was considered to be speed was one of the concerns when people were thinking about Java. Okay, but not so. Fine. That was up to 1.2 or something, but then
After 1.3, I did not heard about slow execution.
1.4 was a tremendous
Stick.
performance
But here in
shift.
virtual machine, not in case of syntaxes, I guess. Not in case of much of syntaxes, I guess.
No. Okay, so lot of performance improvement was done in Java 1.4 as far as I/O was concerned, input output.